So, differential equations. So, differential equation, rather surprisingly, is an equation with a differential in it. And there we go. I'll remember to share my screen as well. So it's an equation with a differential in it. So, for example, dy by dx equals, let's say, 3x squared is a differential equation. So is an example of a differential equation. To solve a differential equation, means to eliminate the differential usually by integration. And you've already solved differential equations in year 1 maths by just integrating both sides. But we're going to introduce a new method that's going to be more useful when differential equations are a mixture of x's and y's. So the extension, the new learning, e.g. solve dy by dx equals xy. So the traditional method of just integrating both sides with respect to x can't be used here because we've got a mixture of x's and y's. So the method we're going to use is called the separating the variables method. And we'll go through it step by step. So step 1, split the dy by dx up into 2 parts, i.e. dy and dx, by multiplying by dx, i.e. treat it as a fraction. Now, this isn't 100% mathematically correct. We're fudging the maths a little bit in order to make it work, because dy by dx isn't a fraction. We shouldn't separate the dy and the dx, but it works too. In this case, it's a good way of thinking about it in order to get the answer. So if we times by dx, we get dy equals xy dx, like that. Step 2, get the y's on the same side as the dy, and the x's on the same side as the dx. And in this case, we can do that by dividing by y. So dividing by y, we get 1 over y dy equals x dx. So far, so good. Step 3. Integrate both sides. So we end up with the integral of 1 over y dy equals the integral of x dx. And I'm just going to pause for a second there, because I said before that it wasn't quite mathematically correct to integrate both sides, to split up the dy and the dx like that. So what I'm going to do is I'm just going to quickly show you, only once, mind, what it is we're actually doing, what the process we're actually fudging by splitting up the dy and the dx, what that process actually is. So I'm going to go back and do this properly for a second. So from here, I get 1 over y dy by dx equals x. And now what I'm going to do is integrate both sides with respect to x, like that. And notice here, the dx is cancelled to give us exactly the same result as we've got here. So mathematically, this is the correct way to do it. However, an accepted fudge, a fudge that you're encouraged to do, is the way I've just done it, splitting up the dy and the dx. But I just thought I ought to show you what's really happening, just that once, so that you can know, you can basically break the rules of maths with confidence. So splitting up the dy and the dx is a quicker way of getting to that result. But mathematically, the way I've just showed you is the correct way. This way is a bit of a fudge, but an accepted fudge that'll get you full marks in an exam. Right, so if we integrate both sides, we get, so the integral of 1 over y is log mod y equals, then we've got x squared over 2 plus c. Now, a question I commonly get asked here is, why don't we put a plus c on the other side? Well, we can, plus c1 plus c2. However, we can just take that constant over to the other side and gather it up in one neat little number there. So it's, again, a fudge that's accepted is not to put a plus c on the left-hand side, just gather it all up as 1 plus c on the right-hand side. And actually, by this point, we've solved the differential equation. We've eliminated the dy by dx, which was the aim. By this point, we have found a general solution, it's called, i.e. one with a plus c. So we have solved the differential equation, but occasionally in an exam, it might ask you to solve for y or solve for x, which means write y in terms of x if we solve for y, or write x in terms of y if we solve for x. So step 4, if asked, write as y equals. Now, this one didn't ask. It just said solve the differential equation, but I'm going to anyway. So that e both sides, I get e to the power of, and log of mod e to the power of the left-hand side, we get e to the y. Now, technically speaking, it should be e to the power of modulus of y, but typically we, in differential equations, another fudge is that we ignore the negative signs, because typically differential equations measure a real life thing. It would be usually be in terms of time, say. And that should say e to the log y, by the way, e to the log mod y equals e to the x squared over 2, and the plus c needs to be in the power. So, sorry, what was I saying? I was saying that we should, we typically ignore the negative values of y, because that's usually a variable, I don't know, time or something like that. or population or something that typically won't be negative. So that would, so I'm going to do the same here. I'm going to fudge it and ignore the negative parts to just say e to the log y, which is y, equals e to the x squared over 2. And adding something in a power will be the equivalent of timesing by e to the c. Convince yourself that that is the same as the line above. And the common question would be to write this for y, but in a nice form. So e to the power of c is still a constant value. So we're timesing by a constant. So typically this would be written as something like this, ae to the x squared over 2, like that. So it seems that what I've told you so far is there's a lot of fudges involved in this. Let's do another. So let's pick, I've got one here. Let's solve this one. If I can get it to appear on the screen. Oh. Try again. There it is. So see if you can solve that using the method I've just shown you. Split up the dy and the dx first. Get the y's on the same side as the dy, the x's on the same side as the dx, then integrate. I'll give you a minute on that before I give you a bit of guidance. Right, so split up the dy and the dx. So that means that dy equals x squared minus 2 over y dx. And notice that the y's are on the wrong side. They need to be attached to the dy. So if we multiply by y, we get y dy equals x squared minus 2 dx. And now we're ready to integrate. Which means that y squared over 2 equals x cubed over 3 minus 2x plus c. And we were just asked to solve. Nothing else. Therefore, we're done. I'm not going to make it say y equals because we weren't asked to. I'm going to try another. This is going to bring into play all of your integration methods that you know. So there's another one there. Have a go at that one. So separate the dy and the dx. I always like to put brackets around it to illustrate that it's all of that y minus 3 attached to the dy. And notice that the y's are on the wrong side. We've got some y's attached to the dx. We don't want that. So we get y minus 3 all divided by y minus 1 dy equals x dx. And now we're ready to integrate. But remember what I said about your integration methods and what you need to do. You need to know all about your different integration methods in order for you to be good at differential equations. So if you feel your integration needs work, that's something to work on before practicing and attempting more questions on this. So tell you what, type in the chat box what you think the method is to use here. Yeah, Matiana, I agree. Partial fractions. Yeah, Chloe, partial fractions. Good. We need to split this up into partial fractions now in order to be able to integrate this. It's just not doable otherwise. So let y minus 3 divided by y minus 1 be identical to a over y plus b over y minus 1. Multiply by the denominator. We get y minus 3 equals a times y minus 1 plus b times y. And let's sub in some tactical values to find out the values of a and b. So let's let y equal 0 first, which means that minus 3, the left-hand side, equals minus 1 lots of a, meaning, in this case, a equals 3. Let y equal 1, which makes the y minus 1 disappear. Meaning, so 1 minus 3 is minus 2 equals b. So there we have it. So now the left-hand side of the integral becomes the integral of 3 over y, and b is minus 2, so take 2 over y minus 1 dy equals 3 log mod y minus 2 log mod y minus 1. And the right-hand side we see is the integral of x dx equals x squared over 2 plus c. So let's conclude. Therefore, 3 log mod y minus 2 log mod of y minus 1 equals x squared over 2 plus c. And we were only asked to solve, so that's done. We have solved, we've eliminated the differential, and that's it. One thing you might be asked to do is find a particular solution, so actually find the value of the plus c. So let's have a go at one like that. So in this one, we need to find the value of the unknown constant as well, using this point here. Once we've solved the differential equation, find C by using that point. And these are often referred to as boundary conditions. You might see them referred to as boundary conditions. So have a go at that and find the plus C. Then I think we're probably ready to look at some exam questions. So I'm going to quietly get on with this, hopefully while you're still going at it. The trick here is to split the surd up, or rather the root sign. We don't know if it's irrational. The root sign up into two parts like that. Like that. And we should always find the plus C at the earliest opportunity, even if it asks us to solve for Y or solve for X. We should always find the plus C, if we can, that is. So as soon as the plus C appears, find its value, if possible. So we've got our boundary conditions there. So let X equal 1 and Y equal 16. Which means that 2 lots of 16 to the power of a half equals 2 lots of 4 to the half plus C. So being really, really lazy. So, nah, I'm not going to be that lazy. So 2 lots of 4, 8. 2 lots of 2 is 4. So 8 take 4 is 4 equals C. And then just conclude with the answer. Probably is nicer to write it in normal form like that. 2 root of x plus 3 plus 4. So quite often, differential equations question can be asked in a certain context. So let's have a look at a couple of exam questions to do with this now. So there's one there. Have a look at that one. Solve the differential equation, that there, given the particular solution that satisfies the condition y equals 4 when x equals 5. Again, it hasn't asked us to solve for any particular variable. Therefore, just eliminating the differential is enough. I would go with that one. Right, I'm going to quietly get on with this now. You can check your answer against mine. Actually, I'll probably use the margin properly here. There we go. Then putting the y and x in. And I will get lazy here. When I say lazy, it's perfectly reasonable to use the tools that you've got. minus 3 over 2 is C. Therefore, concluding, we've got y squared over 2 minus 3y equals 2x minus x squared over 2 plus, or rather, take 3 over 2, like that. And that's good enough to get the marks. It's only asked us to solve the equation, not solve it for a particular variable. So part 2. So that can be expressed in that form. I'll give you 30 seconds if you haven't already got that far. So I think it makes sense to times everything by 2 first. Okay, so we can see that this is a particular type of equation that you're used to seeing. So take everything over to the other side. And it's a circle equation. So we complete the square. X minus 2 squared minus 4 plus y minus 3 squared minus 9 equals minus 3, which means that x minus 2 squared plus y minus 3 squared equals 10. And we don't need to explicitly state A, B, and C because we've done so in writing the equation. But if you really want to explicitly state them, you can say that A equals positive 2, B equals positive 3, and K equals positive 10. I say positive, you might be tempted to write negative 2. However, the question here already has the minus sign there, so we've got to be careful. Right, let's do a question with a situation involved now. The height h meters of a shrub t years after planting is given by this differential equation here. A shrub is planted when its height is 1 meter. Quite often you'll find that parts of the question have information hidden in them, i.e. boundary conditions, points hidden in them. This is such a question. A shrub is planted when its height is 1. So at t equals 0, i.e. when it's first planted, h equals 1. And that's going to be useful later. Always get as much information as you can out of the question before starting it. Okay, show by integration that t is equal to that. You go for it. The method we've just discussed, that we've just been doing, have a go at applying that to this question now. I'll just get on with this now. Feel free to ask any questions in the chat box if you want about what I'm doing. And notice what I've done here. I'm taking across to the other side the bare minimum that I need to take across. Constants sometimes just get in the way. So rather than times by 20 and divide by 6 minus h, the only thing I really need attached to the dh is 6 minus h. So it's most likely going to make it a simpler integration if I only take across the bare minimum that I need to. Might not make it simpler, but it certainly won't make it any harder, which taking across the 20 just might. So if we now integrate ln mod 6 minus h equals 1/20th t plus c. Now the schoolboy error that I've made in this one, that in an exam, quite often they'll try and catch you out with, what's the mistake? That's quite difficult to spot unless you've made it before and been picked up on it. What's the mistake I've made here? Feel free to type it in the chat. Yes, it should be minus ln. Well done, both. Because what I need to do here, I need to divide by the differential of what's in this log, divide by the differential of the bracket. So divide by -1, which makes it a minus at the front there. Now let's find the plus c. So my advice was find the plus c as soon as it appears. So let's do that. So let t equal 0, h equal 1. And if you hadn't spotted that in the question, this bit wasn't really doable. We couldn't progress any further. Which means that minus log and h is 1. So minus log 5 equals c. Therefore, minus log mod 6 minus h equals 1/20th t minus log 5. And this illustrates why we ignore the minus part of this. It's modulus. So really, we should keep the modulus in there if we're solving it as a pure maths question. However, it's an applied situation. So in reality, we're never going to get this b negative. So we'll just discard, or rather, we're never going to get this 0 or below. So we'll just typically discard the modulus as being unnecessary. Which means that log 5 take log mod 6 minus h, and I'm going to get rid of that now, equals 1/20th t, using logarithm laws, which means that log of 5 over 6 minus h equals 1/20th t, which then means that t equals 20 log of 5 over 6 minus h, as we were required to show. Part 2. How long after planting the shrub will it reach a height of 2 meters? Well, let's let h equal 2 and find out. Is that the time is 20 log of 5 over 6 minus 2. So 20 log 5 quarters, which is 4.463. Let's have a look at the units. The units were years, so let's put the units years like that. Part 3, find the height of the shrub 10 years after planting. Okay, let t equal 10. Which means that 10 equals 20 log 5 over 6 minus h. And rearrange that to find h. I'll give you a moment to do that. And I'll just put the final part down here in case you need it. There it is there. .967 meters. And then part 4, which you can see here, just one mark, state the maximum possible height of the shrub. So as the shrub grows and grows, it's going to get up to 6 meters, which is going to break the equation. So actually, 6 meters is the asymptote of this. So the maximum possible height of the shrub, I disagree with the wording of the question, actually. I think it should say, what's the limit of the height of the shrub? It will never reach 6 meters due to this equation because 6 will break the equation, but it will get forever closer to 6 meters. So 6 meters is the answer. 6 meters we can see is an asymptote. Now, more difficult are questions where you've got to make the equation yourself, like this one here. And this is closely connected to connected rates of change that we did last time. You make the equation from the information given in the question, just like you started off getting the information out of the question in the connected rates of change topic. So use the same method. So water flows out of a tank through a hole in the bottom. At time t minutes, the depth of water in the tank is x meters. At any instant, the rate at which the depth of water, stop reading, the rate at which the depth of water is decreasing. So x was depth. So the rate of depth is dx by dt. So the differential equation is hidden in the question. So before I even read what the question's asking, I'm going to write this down. Is proportional to equals k times the square root of the depth of water in the tank. So my answer there is 100% correct. How could I improve it, though, to make it better presented? What would illustrate the information that I've underlined slightly better? Yeah, decreasing. So emphasize that the constant's negative. Truth be told, if I'd left it as k, I'd still be right. I'd just get a negative value for k. But now I'm going to get a positive value for k, which the minus sign then makes negative. So the negative isn't necessary, but it's just a good thing to do if it says that it's decreasing. And I've accidentally answered part 1 as well. In writing down that information, I've accidentally answered part 1. They will not always give you that information, though. Or rather, the question won't necessarily say, write down a differential equation. You might be expected just to do it yourself. So this could be an 8-mark question that just says, solve the differential equation. Right, part 2. I'll leave you to have a go at that. I'll give it a few minutes, then I'll take over. Okay. And if you leave the k attached to the root x, when you take it over to the other side, it does make the integration slightly more difficult. So all I'm going to take over is the root x. So subbing in the bits of information we've got. So t equals 0, x equals 2, implies that 2 root 2 equals c. T equals 5, x equals 1, implies that 2 lots of root 1 equals minus k times 5. plus c, which we know is 2 root 2 now. Which means that k equals 2 minus 2 root 2 over minus 5, or timesing that by minus 1 over minus 1. We don't like negative denominators. Don't know why we don't like them, but it's just something that is programmed into us not to want to see. So we've got that there. Therefore, so it's not even asked us to solve the equation, just said find t when x is 0.5. Therefore, when x equals 0.5, this implies that so 2 root of 0.5 equals, I'm going to leave it in terms of c and k, so I don't have to write out these monstrosities every time. Well, actually, 2 root 2 isn't so bad to write out, is it? Which means that 2 root of 0.5 minus 2 root 2 divided by minus k equals t, which is equal to, so 2 root of 0.5 minus 2 root 2 divided by minus k like that. It's equal to 10 plus root 5 over 2, 10 plus 5 root 5, so 10 plus 5 root 2. Tidy that up a bit. 10 plus 5 root 2 over 2. Yeah. But we're not done yet. It said give your answer correct to 1 decimal place, which is approximately equal to 8.5. And the unit is minutes. Hope you found that useful. That's us done for today. Have a good rest of the weekend. And hopefully you're all refreshed to start learning again back on Monday. Not long now till we're back in colleges and schools, hopefully. Fingers crossed for the 8th of March. See you all later.